All right, our discussion of electricity has brought us to resistance, which is a key idea in considering circuit components and how they behave inside of a circuit. There are several different kinds of resistances, at least a couple different kinds, but the main component that we think of as having resistance is a resistor. This is the British symbol for a resistor. American symbol is a little bit different, but that's fine. We're focusing on the British symbol. These are what they look like. Again, they have a variety of appearances. They usually have these colored bands on them. Those colored bands allow you to calculate the exact resistance, or to tell what the resistance is of this guy, and that's why they're on there. They're put there by the manufacturer, in any case. Another thing that has resistance is a lamp. Basically, anything that uses electrical energy has some degree of resistance. So let's talk about a little bit of text, a little bit of definition going on here. So electrical resistance is a numerical measurement of how easily current flows in a circuit or circuit component. You may have noticed on the previous slide it said electrical resistance is a measure of how hard or easy it is for current to flow through a certain component or circuit. All right. We generally call a circuit component a load if it uses electrical energy. So that's just a generic term called a load, an electrical load. So there's two basic types of loads in a circuit. One is a load that has constant resistance. Basically, it doesn't change much based on the current or voltage that is supplied at any given moment. The resistance stays the same. It does not vary based on current or voltage, and it doesn't vary based on anything that I do to it. Basically, a component that has constant resistance is basically always the same resistance, pretty much, under any normal operating conditions. Now, variable resistance is the other kind of thing. And the resistance of a load can change based on quite a few different things, actually, depending on the material and what's going on in the circuit. We'll talk more about certain specific, unique, interesting circuit components that have a variable resistance that changes based on factors like light levels or temperature. So those are really useful things of certain types of materials, and those components would have a variable resistance, not constant. But some loads do have a constant resistance, and those are the ones that we use for making resistors, properly termed resistors. All right. Okay, so what is a proper resistor, as I was just saying? Well, a proper, quote, resistor, an ohmic resistor, the kinds of resistors that you see with that shape of like the cylinder shape with kind of like looking like a little brown thing on the circuit board a lot of the time, that kind of resistor is one that is a constant resistor. Other kinds of resistors, like we said, are variable resistors. Now, if we were to plot these, they might look something like this. This would be like a lamp with a filament right there. But the ohmic resistor would look like this right here. All right. So if you plot it, current versus voltage. Now on these lines, you'll notice that they have a constant slope. So that's showing that it's a constant resistance, because now it's interesting that this is plotted this way with current on the y-axis and voltage on the x-axis. You could plot it whichever way you want. But the resistance is equal to the voltage divided by the current. So it's potential difference divided by current. So it's a little bit weird. On this particular graph, the slope is not actually equal to the resistance. We'd have to have voltage on the y-axis and current on the x-axis in order to get the slope equal to the resistance. In any case, plotted this way, it's a little bit weird. This is actually a high resistance line. This line would be a resistor that has high resistance, and this one would be a resistor that has low resistance. So high resistance, as you increase the potential difference, voltage gets higher and higher and higher. You don't get that much more current because the resistance is high, and resistance slows down the flow of current. Now here, as you increase the voltage, increase the potential difference, you're getting more and more and more current. So that just shows that this is a lower resistance. It has less, it impedes the flow of current less. There's less stopping the flow of current. So as you increase the push or the potential difference, then you just get more current faster if there's less resistance. All right. Now a filament lamp is entirely different. It is not a constant resistance. In fact, the resistance changes with voltage or with potential difference. So starting at a low potential difference, you have actually low resistance and the current increases rapidly. But then as you increase the potential difference more and more, you actually get higher and higher resistance to the point where, you know, it's almost asymptotic. It's almost going to just stop completely increasing in current. Even though you give it tons more voltage, it still basically is not increasing anymore in the current that's flowing. So that's two different kinds of resistances there and what they would look like if you plot them. So here's a variable resistance, and it basically varies as the potential difference increases, the resistance also increases. So higher potential difference means higher resistance to the point where basically you have a very high resistance and getting hardly any more current with the increasing of the potential difference. On the other hand, an ohmic resistor, increase the voltage, you'll just keep increasing current at a steady rate. There's no change in the resistance based on voltage or current. So at this point, it would be appropriate to show you guys the formula, the mathematical relationship among current, potential difference, and resistance. So simplified, the potential difference is equal to the current times the resistance. And then if we use symbols, V for potential difference, because it's measured in volts, I for current is I, and then R is resistance. So V equals IR. And then if we want to put it in terms of calculating for resistance, resistance is equal to potential difference divided by current, or V over I. All right. Cool. There's more to say about resistance, but we're going to save that for another video. Thanks for watching, and we'll see you next time.